So far we've been examining the equation of a polynomial, and then from that we've been determining what the degree is and the sign of the lead coefficient, and that helps us get what the end behaviors are. If we have it in its factored form, we know what the x-intercepts are, and based on the order of the x-intercept, in other words the exponent of the factor that is that x-intercept, we can decide what's happening at that x-intercept for the graph. Okay, so if we look at this, our goal today is that we can determine the equation of a polynomial function, so working backwards this time, in its factored form and standard form from its graph, or given its zeros at another point. So determine the equation of this function, f of x, in the graph, in both its factored form and its standard form. So if I look at this function, now you have to understand we are only focusing up to a degree 4 polynomial, so degree 1 is our line, degree 2 is quadratic, degree 3 is our cubic, degree 4 is our quartic. Based on the fact that we have the behaviors that we have here, we know it's an even degree function because the end behaviors are the same, they're both going to negative infinity. We know there's an x-intercept here at 1, and we know there's one here at negative 2, but it's not cutting straight through like a parabola would. In this case, it has to be a degree 4 because it has the twist happening at that x-intercept. So, based on what we know then, we have a function f of x. I don't necessarily know that number in front. I know it should be a negative number based on the fact that both my ends are going to negative infinity, but I'm just going to leave that as a value of a, just like I would with a parabola. I know one of the x-intercepts is at negative 2, which means my factor, working backwards, would have to be an x plus 2. And because it has that twist there, but it's going through, it is an order of 3. The other factor, the other x-intercept is at positive 1, so the other factor would be an x take away 1. Now, the question is, how do we actually solve for this a value right here? And what we need is a point other than one of those x-intercepts that lies on this particular function. And if I look at my graph, it appears to be passing through a y-intercept of 2, which gives us an ordered pair of 0, 2. So that means we can put 0 in where x is and 2 in where the y is, or what f of x is. This, remember, is just y. So 2 is equal to a, and then the 0 is getting, or x is getting replaced with the 0. And then Bedmus says we are going to actually evaluate what is inside our brackets before we apply that exponent. So 2 will equal a, and 0 plus 2 is 2, so we've got 2 to the exponent of 3, and 0 take away 1 would be a negative 1. Now what we have, 2 to the exponent 3 is an 8, and then 8 times negative 1 would be negative 8. So negative 8 times a is what we have on the right side of the equal sign. At this point I'm going to divide both sides by negative 8, and 2 divided by negative 8 would be equivalent to negative 1/4. So my a value is negative 1/4, which then means in factored form, my f of x is equal to negative 1/4, or 0.25, x plus 2, all cubed, and then multiplied by x take away 1. And you could put the x take away 1 first, and then the x plus 2 cubed second. It doesn't really matter. So this is the equation in its factored form. So is the equation in the factored form. Now, if I want to get my standard form, what we did at the very beginning of this unit was expand and simplify. So, at this point, I'm going to expand and simplify that polynomial. All right, now to do that, I'm going to be nice and write that bracket out thrice because it's 3 times. So negative 1/4 times x plus 2 times x plus 2 times x plus 2 times x minus 1. Okay, and then, oops, because I'm going to have not a lot of room here, what I'm going to do is multiply these two together and get its answer, and then I'm going to multiply these two together and get its answer, and then take those answers and multiply them together. I'm going to save this negative 1/4 until last because I don't want to work with fractions any sooner than I have to. So if I multiply x plus 2 with x plus 2, I get an x squared, plus 2x is plus 4x, and then plus 4. So I've just kind of skipped a step there. If you need that extra step, please put it in. The other bracket, multiplying the ones underlined in yellow together, I would get an x squared. A minus 1x and a plus 2x would be a plus 1x, or just plain old plus x. And positive 2 times minus 1 is minus 2. Okay, so at this point now I have a trinomial times a trinomial. Again, I'm going to keep that negative 1/4 just out front, not deal with it yet. I'm going to get an x to the 4 plus x cubed minus 2x squared. So that was multiplying that x through this second bracket. And now the plus 4x takes its turn to multiply. Plus 4x cubed plus 4x squared minus 8x. And then, so that was that one. Now I'm going to take the plus 4 and multiply it through the bracket. We're going to get a plus 4x squared plus 4x minus 8. Close the bracket. And then, again, the negative 1/4 I'm leaving out front. Let's see what we get here. I've got 1x to the 4, and I've got no other x to the 4s to put with that, so that's x to the 4. We have 1x cubed here, 1x cubed here. We've got 4 more x cubes here, and that's the end of the x cubed, so that's altogether 5x cubed. 5x cubed. And then we have a minus 2x squared. We have a plus 4x squared. That's 2x squared. Plus another 4x squared. That would be 6x squared. So that's going to be plus 6x squared. And then let's see what we have next. We have a minus 8x and a plus 4x. That would be minus 4x when I collect those. And then we still have a minus 8 on the end. And then we can multiply everything by negative 1/4. Let's see if I can move this up. Ooh, barely enough room here. I think I can squeeze this in. We're going to get negative x to the 4 over 4, or negative 1/4 x to the 4. We would have a minus 5 over 4 x cubed. Minus 6 over 4, that would reduce to 3 over 2 x squared. And then minus times a minus will be plus. 1/4 of 4 is just 1x. And then a plus, 8 divided by 4 is 4. So I think, whoops, 8 divided by 4 is not 4. Just kidding. 8 divided by 4 is a 2. So I think that should be our final answer in its standard form. So that's the standard form equation. All right, let's move over to the next question, which is giving us determine the equation of the function, so this function, in its factored form and its standard form, and then sketch it. So right now this function is neither factored nor standard. It's kind of factored, but because of this subtract sign right here, it's not considered fully factored. So let's see what we can do with that. Okay, I am noticing, and hopefully you are too, this and this are the same. So if you think of this, if I let, that's supposed to say let, a equal x squared plus 3x plus 2, then I could rewrite that as x squared times a, oh goodness. This thing is going to drive me crazy. Let's go back to another color here. X squared times a, or x squared a, minus a. Now if I treat it like that simple kind of equation, do you see that a is common to both terms? So we could common factor a out, and we'd be left with an x squared and a minus 1, which this piece is a nice little difference of squares. I'm just going to reintroduce what a actually was. It was this thing here, which is a trinomial. So I'm going to replace that. Well, let's do that again. I'm going to replace that a with that bracket. Get the right tool out here. We're going to have an x squared. So the a really is x squared plus 3x plus 2. So you don't actually have to introduce a there, but I sometimes do that to simplify the problem and make it like something that's easier to work with and not so intimidating. All right. this piece, which was a, is really a simple trinomial. We're looking for two numbers that will add to 3 and multiply to 2. Well, 2 and 1 will do that. So my factors for that, it's a simple trinomial, will just be x plus 2 and x plus 1. So that's the factored form of this piece. Oops. And then if I look at my difference of squares, that x minus 1 could be written as x minus 1 times x plus 1. All right, now this is looking better. This is more like my factored form here. I notice that I have an x plus 1 here and an x plus 1 here, so I actually could write that as an x plus 1 all to the exponent of 2. So I'm going to replace the two x plus 1s with an x plus 1 to the exponent of 2. The reason I want to do that is because I know at that x-intercept, with an order of 2 there, I'm going to bounce off the x-axis at that value of x. So my x-intercepts would be -2. So x equals -2 comes out of that factor. X plus 1 equals 0. That means x equals -1. And this last one, x would equal +1. Goodness, I'm having a terrible time here. There we go. So I know my x-intercepts. If I were to expand and simplify this all out, I'm going to get a degree of 4 because I have an x times an x is x squared times another x is x cubed times another x will be x to the 4. It's degree 4 with a positive lead coefficient. So that means my end behaviors both go to positive infinity. So now if I go to sketch that, I'm going to have an x-intercept at -2, at -1, and at +1. And at -1, we have a bounce happening there. So positive infinity, it's going to come around, it's going to bounce off of that one. We're going to have a y-intercept, and then it's going to loop-a-loop like that. So there's my g at x function, graphed, sketched, just sketched. And I really should be labeling my axes, and I'm also going to label where those zeros were. So they were at -2, -1, and at 1. And the other thing I could figure out is the y-intercept by evaluating g at 0, which would give us 2 times 1 squared times -1, which is 2, -2. Diagram not quite to scale, but not too bad. Oh goodness, I'm not sure what I'm doing here. There we go. -2 is my y-intercept. So that would be sufficient. Technically, I should use a ruler, but I haven't. Now the last thing we need to do is a complete on expand and simplify and write it in its standard form. I would probably go back to this original version here because I think it would be easier to expand and simplify than working with like these ones down here. So I'm going to do that. You try it, see what you get. And I'm going to put the video on pause. You should put it on pause. You should try it out, and then you can check your work. Okay, and I have my standard form here, my final standard form. You'll notice that the last number here is -2, which is our y-intercept. So we could have waited until we got our standard form to get what that y-intercept is. And clearly it's a degree 4. Lead coefficient is a +1. So we're good.